This lesson's on combinations. Combinations are a lot like permutations. It's a way of calculating how many different groups you can make, but in this case, the order of your objects do not matter. It's nCr on most calculators. If you don't have that button, it'd be n factorial divided by n minus r factorial and another r factorial. So if you were going to make, you have 20 people, you want to make groups of 5, it'd be 20 choose 5. Or 20 factorial over 15 factorial divided by 5 factorial. But most calculators have that button. Again, you use this button when the order doesn't matter. So if we're going to go through this note, we're going to talk about when the order matters, when it does not matter. First example we're going to use here is you walk into an ice cream shop that has 25 flavors. How many different ways can you choose 4 flavors for your 4 friends if A, they do not care what flavor they get. They don't care what flavor they're going to get, just as long as they get a flavor. They don't care if the first person gets chocolate, the second person gets vanilla. They don't care what order it comes out, just as long as they get some ice cream. Maybe 25, choose 4, which you can put that into your calculator. 25, choose 4, okay, equals 12,650 different ways that this can all get sorted out. Different groups of 4 you can make out of the 25. You're not using all 25 flavors, you're only using 4 of them. If you're using all 25 flavors and you want to do the number of orders, then it'd be just 25 factorial. But here I'm not using them all, and the order does not matter. If they do care what order it comes out in, then it'd be 25 permutations for P4. If they do care, the first person gets this one, the second person gets a different flavor. Okay, but if the order does not matter, then it's 25 choose 4. Second example, teacher has 20 students in his class. How many groups of 4 can that teacher make? Okay, now the groups of 4, they don't have specific rules, they're just put it into a group. It doesn't matter who's picked first, who's picked second, and whatnot. So not using all 20, it's only making groups of 4. 20 choose 4. Okay, if they had roles, if each person, so the first person was kind of like the president, the second person was the vice president and whatnot, the secretary, treasurer for each of the groups, and each one had a role, then it'd be 25 P4. But that's only if there was roles involved. If there's not, doesn't matter the order you're getting in, it would just be 20 choose 4, which is 20 choose 4 equals 4,845. Now if you didn't have a calculator, or that had that button, it'd be 20 factorial divided by, and it'd be n minus r, so 16 factorial, divided by your r factorial again, which would be 4 factorial. Okay, that'd be if you did not have the calculator with that button. Johnny has 7 pants, 12 t-shirts, 6 pairs of shorts you can choose from. He's packing for a trip and wants to take 3 pants, 7 shirts, and 2 shorts. So he's not using all the pants, not using all the shirts, and not using all the shorts in his closet to take. And now he's packing the suitcase. It doesn't matter which one gets in first, which one gets in second, which one gets in third. It just as matters in the suitcase. He can sort it out when he's later on his trip. So he's going to have 7 choose 3 for the pants. He's going to have for the t-shirts 12 choose 7. Again, the order that the t-shirts are in does not matter. And then he's going to have 6. He's not using all the shorts. He's only going to use 2 of them. Choose 2. The order does not matter. Now, he needs to have all 3 of them in there. So this is an AND situation where you're going to have to multiply all 3 together to get your answer. Okay? He needs to have his pants and his shirts and his shorts. Now, if the order mattered, so where he cared about, okay, I want my Monday clothes on top, I want my Tuesday clothes afterwards, and the order that he put the stuff in did matter, and he was kind of packing it by the individual days, then it would be 7 P3 and 12 P7 and 6 P2. It would be still permutations because he's not using all the available options. If he was using all 7 pants, then it'd be just 7 factorial. If he's using all 12 shirts, then it'd be 12 factorial. But because he's not, it's either going to be a combination or a permutation. And it's a combination if the order that he puts it in does not matter. And usually in the question it will kind of specify. All right. Now the numbers you're going to get, the permutation numbers you're going to get will be much larger than the combination. Okay, and that's because every new order you put in is a new scenario. If you're playing cards, okay, when you're playing cards, the order that you get your cards doesn't really matter for most games. It just doesn't matter that you actually get it in your hand, that you have it there in front of you. Doesn't matter if it's the first card dealt or the second card dealt and whatnot. Most standard card decks have 52 cards. Okay? How many possible hands of Crazy Eights are possible? Now in Crazy Eights, if you don't know the rules, you get dealt 8 cards out of the 52. You're not dealing with all 52 cards, you're only dealing with 8 of them. And the order does not matter that when you get your cards, so it's going to be 52, choose 8. Okay, which would be a large, very large number. 52, choose 8. 5. So we have 150, 752,538,150 total different hands possible for Crazy Eights. Okay. Now actually that would change, that's for the initial scenario. Now that would change based on the number of players as you start dealing cards out. How many hands with 3 face cards are possible? Now in this case you're going to have 3 face cards out of, and now face cards are your jacks, queens, and kings. There are 4 of each because there's 4 suits, so there will be 12 in total. And your non-face cards, so I'm dealing with hands of Crazy Eights, so there's 8 in total, so there'd be 5 non-face to give me my 8 cards. And there's 40, because there's 52 cards, 12 face, and there'd be 40 that are not face. So I'd have, out of the 12 face cards, I need 3. And, so multiplying, I have 40 non-face cards available, and I need 5 of them. So I would multiply these two together to get my final answer. You have 52 in total cards, 12 are face, 40 are not, and I need 8 of them. 3 face, and then that would make 5 that are not face. So again, order determines whether you're using permutations or combinations. If the order matters that things happen, it's permutations. If the order does not matter, it's combinations. In that these are all scenarios where you're not using all available options. If you're using all of them that are available to you and you kind of have the countdown going on, then it's just simply factorial. Where the order matters would be like spelling your words. Okay, the order matters. So the letter, each way you organize the letters in a word is it creates a new word. So the order actually matters. If you're playing cards, the order does not matter. If you're making groups and you're not given specific roles, then the order does not matter. If you're given rules, then the order does matter, and it's permutations. If I'm creating a seating plan as a teacher, where students sit, the order matters where I place the students. Okay, so that'd be a permutation. If I'm using all the students, I have the exact number of students as I do desks, then it's just simply factorial. But if I had more desks than students, then it's just permutations. If I'm running a race, it matters what place you finish, gold, silver, bronze. Okay, the order matters, it's permutations. When you're creating starting lineup for your teams, if it just matters who's on the field, doesn't matter the position, then it's a combination. If it matters what position they get put into, then it's a permutation. Okay, so this is a short lesson on combinations where the order does not matter. Thank you very much.